consider the function f of x equals 2x cubed plus 9x squared minus 60x plus 5 in the interval -5 to 3. The function has an absolute maximum or minimum value, which is equal to what at x equals what. So we're looking for what's happening with this function. We're not going to use the graph this time. We're just going to use the knowledge of what's happening analytically. So maximums and minimums would occur where critical values happen. So let's check out a critical value. So let's find our derivative, which is 6x squared plus 18x minus 60. And we set that derivative to 0. And you know, there's a common factor of 6 in each of these. I'm going to just divide that out. Which means that'll make my factoring process easier. So 5 and 2. And if it's a positive 5 and -2, so x equals -5 and x equals +2. Now, here's the thing. Notice my interval. This interval says x has to be greater than -5. So this point right here isn't technically on my interval, so I don't really need to concern myself with it. So it's really only the +2 that's an option. So I need to figure out if +2 is an absolute maximum or an absolute minimum. So let's see. So it happens at x equals 2. The maximum or minimum value is of course going to be f of 2, which I'm just going to use the calculator to get. So put that into put it into y1 and use the list. So 9x squared minus 60x plus 5. All right. Oh, I didn't mean to graph it. I meant to use a table. All right, so if I plug in 2, I get -63. So the absolute maximum or minimum is equal to -63, and it's at x equals 2. But the thing is, we don't know yet if this is an absolute maximum or an absolute minimum. And don't just jump to the conclusion that it's a negative number, so it must be a minimum. You can have a maximum value that happens to be negative. You can have a bank account that you are in the negative, but you pay some money toward your bank account, and that brings you closer to 0. And then you spend some more, and that brings you further away from 0. So your maximum could be negative. That can happen. So don't jump to that conclusion. So to determine if this is a maximum or minimum, the best we can do really at this point, which we'll have a better way shortly, but the best we can do at this point is look at the graph and just see what it is. So if I were to graph it, it doesn't show up very great on this particular scale, but here's the 0 at, well, that should be at 2. Let me check something. 2x cubed. Sure. Oh, they're not zeros of the polynomial, obviously. They're zeros of the derivative. All right, so I could try and look outward and just change my window. Maybe the y values, let's make it -100 to +100, and see if I can get a better picture of this particular graph. All right, so that's good. So here's -2. So I can see on the graph, this point right here is a minimum. So it's an absolute minimum. There is an analytic way of determining that, and we will use that later in the course. But for now, that's really all we have at our disposal.